So hello to everybody, good afternoon. And today I would like to speak to you about the Mars Sample Return Campaign. And this is a mission which will bring back to Earth the first samples of Mars soil. So before starting, I would like to introduce myself. I'm Leonardo Bertelli and I'm 26 years old. I've been studying robotics engineering at Politecnico di Milano, and in the past 2 years, I've been working in the space robotics field. While here you can note my big smile standing next to Perseverance rover in Pasadena in JPL, NASA. And so let's start. I've said that it's a mission about Mars, and I would like to give you some basic statistics about Mars. So its distance from Earth is more or less 200 million kilometers. It's the planet next to Earth, and it takes 9 months for a spaceship to reach that planet. So the distance is very large. And also about the temperature, you can note that it's very cold, and this can create lots of problems, especially in the electronics, which have to be designed to resist to these extreme temperatures. So that was the where. Now let's see the why. These are the goals of this mission, that is, bring back to Earth these samples containing precious Mars soil. And we want to bring those samples back to our planet to search for traces of life on Mars, and also understand the geological history of this planet, and finally pave the way to future human exploration mission. So let's start with the team. These are the players which will make this mission possible. Now I would like to go through any of these. And let's start from Perseverance rover, or Mars 2020. Here you can note this rover, and while we are here talking, this rover is already on Mars drilling the surface. He is already there. And this rover is equipped with wheels so that he can move around Mars autonomously. It has a camera to see the environment, to perceive the environment, the obstacles, and so on. And the power source for this rover is nuclear. It's not based on batteries or solar panels. And you can note the most important part of the rover, which is a robotic arm with a drill on the top of it. So this drill is going to drill samples from Mars and store them in sample tubes. And here you can see an image of these tubes. These are more or less 15 centimeters long, and they contain the precious Martian soil. And once these tubes are filled, some of them are kept from the rover inside himself, while others are left on the ground. And later we'll see why. Now let's go back to Perseverance. Here you can see a picture of the rover in a clean room in NASA JPL. A clean room is a room which satisfies certain standards of cleanliness. And it's very important because for a mission like this one, we don't want to discover traces of life on Mars, but then discover that in reality they are human traces which were brought there from our planet. And also, we don't want to bring human bacteria to Mars. We don't want to contaminate that planet. So this is why the rover is mounted in a clean room before being sent on Mars. Also, I would like to give you an idea about how the autonomous navigation works for this rover, because this rover is far away from our planet and he has to carry out all the mission by itself. So I said that the rover has a camera, and thanks to this camera, the rover can map the environment and build a map of the environment. And once the map is ready, it can be possible to assign a goal to reach to this rover. And at that point, the rover has to think, okay, I can go straight, I can go right, or I can go left. Then the rover assigns a score to each one of these trajectories based on how much a trajectory is near the goal or how much a trajectory is dangerous. So at the end, the rover picks the trajectory with the best score and tries to follow this trajectory by moving accordingly his wheels. So this is how the pipeline of the autonomous navigation works. Now let's switch to another system, to another player of the mission, that is the sample retrieval lander. So this is a lander, it has no wheels, it stays still. The power source is not nuclear, but it exploits solar panels, and they have to be designed in order to guarantee that the dust doesn't damage them, because during the lifetime, Martian dust can go above these solar panels and decrease their efficiency. So, as I said, this component is steel, but it's not boring because it's full of other components, very interesting. And so the first one is the orbiting sample container. You can note it in the picture. And this orbiting sample container simply contains the tubes, the sample tubes, which are drilled from Perseverance. And this is a basketball size container. And at the end, the whole mission is to bring back to Earth this container full of the Martian soil. But there may be a question: how do we bring the sample tubes, which are inside Perseverance or on the ground on Mars? How do we bring those tubes into this container, which is into the sample retrieval lander? Well, for the ones inside Perseverance, it will be Perseverance itself, which will come back to the lander once the mission is completed. While for the sample tubes which are on the ground on Mars, it will be the sample fetch helicopter. So this is a new component, a new player of the mission. This is a tiny helicopter with a small robotic arm, and his task is to fly around Mars and pick up the tubes laying on the ground and bring them back in front of the sample retrieval lander. This is the successor of the helicopter Ingenuity, which is flying now on Mars with Perseverance. And Ingenuity is the first robotic system which fly on Mars. Before that, there has not been a flight on Mars. So up to now, we have arrived being with the sample tubes in front of the sample retrieval lander. Now the question is, how do we transfer them from the ground or from Perseverance into the orbiting sample container? Well, luckily for us, there is the sample transfer arm, which is, as you can see, almost 2 meters long robotic arm with 7 degrees of freedom. And the task of this robotic arm is to pick up those sample tubes and insert them accurately into the container. And again, this operation has to be done autonomously without human intervention. So the robot has to be autonomous. And for this reason, it's equipped also with a camera, so as that they can see the environment, perceive where the tubes are, recognize them, and handle them accurately without damaging other parts of the lander, for example. So once the sample transfer arm has transferred all the sample tubes into the orbiting sample container, these tubes are ready to come back to Earth. But before, they have to leave Mars. And to do that, it's envisaged to use the Mars Ascent vehicle. And this vehicle is simply a rocket. So once the container is full, the sample transfer arm will close the lid of this container, and the rocket is ready to lift off from Mars. And again, this is the first time that a rocket lifts off from Mars. It's something never accomplished before. So once the Mars Ascent vehicle lifts off, it will reach the Martian atmosphere, and at that time, it's ready to release the orbiting sample container in the free space. So this basketball-sized container will float in the free space until the Earth Return Orbiter will catch it on the fly. So this is a new component, a new player of the mission. And so the Earth Return Orbiter will pick this container, and inside it will be responsible to clean the external part of the container, because we didn't want to bring human bacteria to Mars, but also we don't want to bring potential Mars bacteria to Earth. So to respect safety standards, this Earth Return Orbiter will clean the external part of the container, while the internal part, containing maybe traces of life, will be opened in safe buildings on our planet, respecting all the safety standards. So at this point, the Earth Return Orbiter is ready to come back to our planet. So he will start its 9-month journey towards our planet until it will reach a distance close to Earth. And at that point, it will release the orbiting sample container through the Earth entry vehicle. And at the end, this vehicle will smash on our planet, containing the orbiting sample container. And at that point, the sample tubes will be on our planet. And at that point, the whole mission could be considered completed. And then the mission will be carried on by scientists on our planet, which will exploit the best structures, the best laboratories to study those precious Martian samples. So some words about the schedule. I've said that Perseverance is already drilling Mars while we are here talking. It landed on 2020, while the next one to leave will be the Earth Return Orbiter, which will orbit around Mars, waiting for the sample retrieval lander, which also contain the Mars Ascent vehicle and the sample transfer arm. And at the end, later than 2030, those samples will be back to our planet. Now I would like also to use some words about the landing on Mars, because it's a very tricky mission, because the spaceship has to go from a velocity of 20,000 kilometers per hour to 0 in 7 minutes. So lots of things happen, and I would like to describe the steps. So first, to go from 20,000 kilometers per hour to 2,000 kilometers per hour, it will be used a space heat shield, because the contact with the atmosphere will decrease the speed, but it will generate lots of heat, and a space heat shield must be used. And that heat shield can reach also 2000 degrees, so a very hot temperature. So at that point, the spaceship is traveling around 2000 kilometers per hour. And at that point, it can be used a parachute to decrease further the velocity. And the parachute will bring the spaceship to 300 kilometers per hour. And at that point, the heat shield is removed, the parachute is cut, and the rockets are switched on. And these rockets bring the spaceship from 300 kilometers per hour to 3 kilometers per hour. And in the last part, when the spaceship has reached an altitude from the soil of about 20 meters, it can begin the sky crane maneuver. That is, the rover is lowered through a cable. In the meantime, the legs of the rover are unstowed, and at the end, the rover can touch safely the Martian soil. And all these steps happen in only 7 minutes, completely autonomously. So it's a very big part of the mission in reality. And also, I would like to show you the control room, the center of the universe. And from here, NASA every day control all the robots on Mars. So every morning, an NASA engineer schedule the activities, the task for their robots. They send those tasks to the robots, and they are executed daily. And this in Pasadena in NASA JPL. And to conclude, I would like to show you again the picture I showed you at the beginning. And I hope that now you can see this picture with new eyes, because now you can understand how much complex and bold is this mission. And now you know every component and every task this component has to do. So I hope you can really see these with new eyes. And I thank you very much for your attention, and it has been a pleasure to be here with you this afternoon.
Thank you, Leonardo, and greatly appreciate the presentation and all the insights and updates that you currently have. For the session, we have a few questions that are coming through right now. So one of those questions is, how do you plan to catch the sample in flight?
Okay, you mean in the free space with the Earth Return Orbiter? Well, there will be special algorithms that will track the orbiting container and will adjust the attitude of the orbiting sample container so that the trajectory of the container will be aligned with the entrance of the Earth Return Orbiter. So in that way, it's guaranteed that it's possible to retrieve those samples.
I see. And another question that we have is, has the sample return machine already has been started to be designed?
Sorry,
Has the sample return machine has already been started to design?
Yes, all the parts are more or less been already started to be designed.
I see. Okay, so the question, let me add, as we see, we still have a little bit of time. So the question from my side, how will the Mars sample return campaign contribute to our understanding of the potential life beyond Earth? And what implications might this have for future exploration efforts? What is this going to unlock for the future?
Yeah, so it would be the first time that we can collect Martian samples and bring them back to Earth. This can have a significant contribution in understanding the Mars planet, because we can study those samples with the potential tools we have in our laboratories. Of course, we can't bring all the instrumentation we want on Mars, but by studying it on our planet with our tools, we can really discover a new future maybe for Mars. We can have a new understanding, and also send something on Mars and bring it back home is the first step to send a human to Mars and bring him home. So it's a mission that it's really paving the way to future human exploration, in my opinion.
Another question that we have is from Mikhail. So how the sample tubes will be found on the surface of Mars? Do they have radio beacons?
Yeah, I'm not really updated about that, but probably once Perseverance deploy on the ground a sample tube, it will store the location, so the helicopter can starting the search around that location, and that maybe with computer vision it's possible to detect the sample tube on the ground.
I see. So, okay. So I think that will be the last question. So in terms of the timelines and milestones for Mars sample campaign, so what challenges must overcome in order to ensure successful return of Martian sample? Like what will be the biggest challenges as you currently see?
Everything. Of course, in space, there is the concept of redundancy. That is, for example, helicopters is a redundant part of the mission because let's say, and we don't want that Perseverance fails and it can't move anymore. In that way, the sample contained in Perseverance can't go back to the sample retrieval lander, and so that mission would be completed, would be failed. But introducing the sample helicopters, the sample fetching helicopters, even if the Perseverance rover is stuck, those helicopters can take the backup sample tubes from the ground and bring them back to the sample retrieval lander. So most part of the mission, also the electronics is studied with the concept of redundancy to assure that if one component fails, it doesn't mean that the mission will fail. But of course, it's not really possible to apply the redundancy to every component. So for those parts, a very strong test campaign will be needed to assure that all components works.
I see. Perfect. Well, of course, that's a very complex mission, and we're surely going to be looking for updates that obviously they can find by following you, which, by the way, I just want to announce that for everybody that's here today in the room, or if you're watching the recordings of the convention, you can find the links included for all the speakers, including Leonardo as well, including with his email that you can reach out if you're coming from institution or a company, or you're looking to connect and ask some questions, or just connect because you're curious about Mars campaign or space in general. So you're going to find those details for the questions or whatever that could be. And we're definitely going to be looking for those updates, and hopefully on the IEC 24, we can dive into more of those answers and these insights from you.
I hope so.
Yes, awesome. Well, okay, Leonardo, I greatly appreciate your time. I appreciate for the session, and I wish you a great week and best of luck in this upcoming mission.
Thank you, Martina. I wish you a great afternoon to everybody.
Thank you.